welcome to our 4 presentations on smart cities. We have 3 presenters, Damon, Mike, and Peter Jaco. And we're going to talk about smart cities, but we're going to talk very much about interoperability around smart cities, how we enable these systems that are operating buildings, cities, infrastructure to communicate. So very briefly, I want to talk about what I do. My name is Bill Cleef. I'm the CEO and founder of a company called Asset Mapping. And we look at how buildings work. Now, any organization, no matter what it does, is made up of 3 things, which is people, things, and data. And without any of those things working properly, you then start to experience big challenges within the built environment. We've been involved with the design, the installation, and the operation of these assets. Now, an asset is something like a physical object, a physical asset, such as an air conditioning unit, a CCTV camera, a coffee machine, a pizza oven. Things that, if they stop working, starts creating issues for the employees, the tenants, and also the engineers that operate the built environment. And one of the big problems that we face day to day within buildings is what happens when an asset fails. And at the moment, what's happening is you phone somebody up within reception, they call an engineer, they come to site, diagnose a problem, etc. And that's pretty much how asset maintenance, equipment maintenance is done within cities. And that's costing the UK government, or the UK as a whole, about 10 to 15% of their GDP. And asset maintenance, 86% is reactive. So there's a huge opportunity to start solving some of these issues. And the way that we look at this is, if you have all the data about that piece of equipment, also starting to connect to the real-time systems, and we use Internet of Things to do that, you start reducing some of these big challenges. We also look at connecting some of the historic systems. So most information comes from what's called a CAD system, or at the moment BIM, Building Information Modeling. And having all that data in one place means you're not trundling through files, looking through operation and maintenance manuals, what's called as-built drawings. As well as connecting to these real-time systems, we can start using the Internet of Things, which is essentially a small computer, to start augmenting these aging legacy systems. I'll give you an example. If you had a temperature sensor into a building, it's around about £500. And although the sensor itself is very cheap, about £450 is spent on the systems integration, wiring that system, out of hours work. And IoT offers this new opportunity to use very low cost sensors, stick them on a wall, and start using that as a data set. And it's about how you then merge all that data together, that both the historic, the real time, and when you have that data, start reacting to it. So everybody's heard the term big data, how we look at a huge pool of data and then start finding understanding, so how we start looking at patterns within that data. But what's more important is how you start reacting to that information much quicker, which is called actionable intelligence. If an asset fails, do something about it. We do that by showing that on a real-time Google map. So the engineers, the technicians can see where the asset is, where it's failed, and then they can navigate themselves to that and have all the correct information when they get there. So that's a very brief overview of what asset mapping does. But one of the things we really want to get out of this panel today is the importance of interoperability, what we can do with this data. So rather than looking at some of the other systems you can see here today within the conference, rather than creating walled garden solutions, how we all start working together. How data coming from our system can then be passed on to, say, demand logic, and the work Damon's doing with open standards. So, can I introduce our first presenter, which is Peter Jaco from a company called Puckerly, which is looking at how they use IoT, the Internet of Things, to start augmenting the home.
Good afternoon, ladies and gentlemen. Thank you, Bill. Pleasure to be here. As you can probably tell from my accent, I'm not from these shores. I'm in fact a Canadian. So I've named my company after my favorite sport, which happens to be ice hockey. And this is my puck, and we are called Puckerly. We're in fact working very closely with Intel. In fact, what I have right here is an Intel Gateway device, which is a Intel chip surrounded by some technology that's been built by one of the companies we work with. And basically what we do is embed Intel devices, Intel Gateway chipsets, which are Moon Island, so secure chip-to-cloud gateways into devices, and we use those to do final mile capture around the Internet of Things. So Asset Mapping is one of our partners. We're also working very closely, as I mentioned, with Intel. So if you think about what Asset Mapping's doing, they're using Intel gateways to connect to buildings and building systems, such as building management systems, security systems. We're actually extending that by both providing the gateway platform, but we're building sensor arrays around that. So what kind of sensors? Well, pretty much anything. So, you know, to anything from temperature to light to moisture to CO2 to movement. In fact, by the end of this year, we're working very closely with Intel, as I say, and really looking at their forward strategy. So over the next sort of 18, 24 months, obviously the chips are getting smaller, faster, less expensive. And really looking at Moore's Law, which I think is actually accelerated faster than Moore's original prediction, which is a 2-year kind of refresh. We're seeing technology move much faster. We're also seeing a huge change in where we go with sensor technology. So that, as Bill touched on, the sensors are getting cheaper, but in fact we're now moving into the realm of nanosensors. And we're also moving into an area where we can have nanosensors that do things like mass spectrometry, which actually, in plain English, is chips that can smell. So, you know, we can do things like, you see a lot of big air quality sensors around London. They cost about $4 or $5 grand each. We can actually manufacture those within sort of 12 months or so, or maybe a little bit longer, at kind of, you know, a much reduced price. We're talking in the hundreds or maybe even £100. So that's really going to revolutionize things. We've got all sorts of use cases for this technology, everything from looking at the retail, the restaurant, you know, take them into factories, take them even in a place like bank branches or hospitals. And if you go on Kickstarter or anything, you'll see a lot of sensor uses in the home environment. So, you know, we've actually won a place on a Canary Wharf group is running a Smart Cities innovation program at the moment. You'll hear from Mike, who's one of the winners on that program. We're in the third stream of that program on a connected home channel. So it just shows there's lots of use cases for that. What could these sensors look like in the home? You know, we've been working with a design company that's helping us actualize some of our ideas and build prototypes. We really will work on a principle where we'll have kind of the super puck, and around that, you can see the little sensor technologies. So, you know, these are things that you might want to see in your home. Of course, we can also embed this technology into devices as well. So we're talking to lighting companies, we're talking to engineering companies. So, you know, actually embedding these into ceilings or into rooms, and really creating the home of the future for us. Is going to look something like this. Personally, I'm a technologist, but I get really, you know, death by apps is not my way to go. You know, I think we're going to see so many different applications coming up, but you don't want 20 apps to run your home. You want one environment, which, you know, we're talking to interoperability. We're going to hear more about open standards. We're very much around open standards. We're doing work with HyperCat right now, where we are working with people like Asset Mapping and their application platform programmable interface. So we're going to have a connection into a home environment where we're connecting both building management systems and security systems through gateways. We're also putting in gateway devices, possibly like the one you saw earlier, where we'll have sensor arrays hanging around that. So let's give you a use case. We're working in Wood Wharf. They're running, looking for technology for Wood Wharf, which is a new residential area in Canary Wharf. What we could do is actually have remote monitoring of an apartment. Say somebody's away on a business trip. If there is a flood from the neighbor or there's some mechanical breakdown or fault within that building, we can alert the maintenance people to react and handle that problem while that person's away, clearly with the consent of the owner. But that's the sort of home of the future and how we see sensors working to really help people manage their environment. I won't dive too deep in the tech, but we're really looking at gathering all this, putting it through the pucks, putting it up into cloud. My background, I should be in the other hall actually, and will be later, information security. My background is very much cybersecurity and encryption, but I've been working for many years now around the Internet of Things as emerging technologies. So this will be secure all the way from the sensor, encrypted all the way up into the cloud. And there's a whole bunch of stuff I can go into security, but I won't. But again, I borrowed this slide from Bill. You can see under the real-time data center we're the Internet of Everything, as Cisco calls it, the Internet of Things, where we contribute to that whole picture via having active sensor data. So that's it from me. Thank you very much. And obviously, I'd be pleased to take any questions during the panel session.
I'm Mike Darby from Demand Logic. Thanks for the introduction, Bill and Peter. Demand Logic is a company we set about to unravel some of the complexities in commercial buildings. As we've already touched on, commercial buildings have sensor networks, they have control networks for things like heating, ventilation, air conditioning. And those appliances like heating, ventilation, air conditioning are typically responsible for anywhere around 60 to 80% of the energy consumption in a commercial building. So unraveling what's going on with those systems is kind of key. We're a small new company, and like the best companies, we were conceived down the pub over an argument, essentially. This is me. My background is building services, and I was complaining to some friends who are in much more scientific backgrounds about how difficult it is to actually work out how well a building is working. So we got together through a concept stage, and then we finally turned into a commercial reality. Key to what we're doing is collaboration. So the insight that you can gain from looking at existing systems and working on those analytics can only actually be realized as improvements in the building when somebody actually acts on them. So collaboration is crucial in that. This is a Carbon Trust estimate of the annual energy wastage simply due to badly configured controls. This is never mind mechanical systems. This is about the control systems that are operating those mechanical systems in commercial buildings. That number is quite old, and it's probably quite conservative, to be honest. Here's some of the companies we're currently working with. We've had an exciting year. We've recently installed in 2 iconic buildings in San Francisco. We went out to San Francisco with Innovate UK as part of the Clean and Cool mission, which was quite exciting. So it's a bunch of new startups going out to the States to show them what we're up to. So in terms of the technology, we developed a small device. It's about so big. You need a single device, and to date, we've found it's pretty much unlimited in terms of the volume of data that it can get out of a building. This slide is trying to illustrate a bit about, it's a tiny touch on the complexity of what's going on in a typical commercial building. You've got a huge number of systems. The building management system itself is already installed and is already working on all of these points. Our objective is to poll that data, and by default, we poll everything. So typically, a building management system will be set up to create short histories, generally short histories of key points. We thought it was extremely important to get a history of absolutely everything. When you're trying to assess what's going on in a building, often you don't know what data it is you need until you get to a point where you're stumbling across a problem. So our approach is to gather that data, get it up to cloud servers, frankly, because of the unlimited storage capability in the cloud, and also because of the backup potential. Typically, building management system data will be backed up or stored locally on a desktop-type PC, which eventually overflows, and you lose access to that data. So the idea is that we get that data into Insight and we present that as software as a service to users via a web server. Just to give you an idea of the volume of data, this is a real example. This is not a massive building. It's like a 15,000 square meter office block. Seems to be a pretty typical metric that we're seeing. There's about 25,000 points on the BMS. Those 25,000 points include things like temperatures, humidities, But equally importantly, their user settings as well. So temperature set points, what people have asked the temperature to be in a space, manual controls, so where things have been put into manual override, and also importantly, what the system is trying to do with that information. So where the system is trying to open a valve because it's seen a change in the temperature, we're seeing that what it's trying to do. We're seeing that it's trying to switch on a fan, open a valve, change the speed of a pump, and so on. The point here really is that that's not a massive building, but it's a massive volume of data, and it's incredibly hard for a human to work out if all of those objects are interacting as they should be. In fact, that was my job in the past, and frankly, the way that service is carried out is generally due to insight. It's kind of it's using historical rules of thumb. You're working on complaints, so where there's a complaint in a building, that's where you're focusing the effort. Our thoughts on this are that if you've got this volume of data, you should be using it to get your prioritized list of what's going on. So this is the sort of example of the insight that we come out with. There's an array of dashboards, and if you look on the top right, there's a little bit of this is about the start about the collaboration thing. Under any piece of insight that comes out of the system, however it's generated, there's an opportunity to start making comments and collaborating, adding more and more information to the outcome of what's gone on there. So you can see it's a cyclic effect. The building owners and managers start acting on that insight, the improvements are seen coming through. Initially, when we first started having a commenting approach on things like that, we had used it as a fairly low-key arrangement. So it was literally that. It was writing a comment under something you'd seen, a bit of a pre-ticketing dialogue. But what came out of that was the fact that even that is data. You're generating data from, this is a human input to what the machine is seeing. So that input is as useful as what the machine is telling you. So as the humans are coming up with their insight, there's an opportunity to turn that into action. And this is what's really starting to make an impact for us, or at least for our users on their buildings, is that any of that insight is then turned into an action. It has a placeholder, and you can assess how effective that action has been and what value it has in actually repairing a building. So we're coming up with all sorts of views. We're addressing at Canary Wharf, as Peter mentioned, we're on that Cognicity program there. A problem that we wanted to help them tackle, which we're seeing more and more again, is where you have very large commercial buildings, where you have multi-tenanted areas and landlord areas. And there's a big challenge there in the fact that there's the incentives on getting things working are blurred. If the landlord is passing on energy costs to the tenant, then the landlord has no direct interest in getting that tenant's services working properly, because they're just simply passing on the costs. This is something that Canary Wharf wanted to address. So we're looking at using our system to give their tenants confidence that the landlord system is working properly. They're delivering hot water, cold water, and ventilation to the agreed levels, and that way the tenant is able to focus on their own systems and get those working properly. This is a kind of typical example of the sort of thing we'd see. It's a bit obscure, but to give you an idea of what's going on here, this is a building where effectively each one of those blobs represents a small terminal unit. What we mean by a terminal unit is a small thing in the ceiling that's actually delivering comfort to the space. So it's delivering ventilation, heating, and cooling. Now those things, in a building the size of that one, there's probably about 1,300 of those units. Each of those units can have, in fact, up to 100 of its own data points on it, which is quite a staggering number. What we're doing here is assessing how well each of those is performing over time. So you can see that on this particular chart, something bubbles over to the right, it's unable to control its temperature well. If something starts bubbling up, it's apparently using more energy to achieve that. What we're trying to do is find the things that are using the most energy and the things that are underperforming in an at-a-glance format. That view would have something in the region of 500,000 bits of information behind it, but it can give the maintenance provider a condition-based approach to maintaining their systems. With terminal units that don't have any mandatory maintenance requirement, for example, and bearing in mind that these are all hidden in the ceiling, hard to access, if there's no mandatory maintenance requirement for filters and such like, then if you can see very clearly that a unit is performing well over time, that's not just about its temperature, but about the effort that it appears to be putting in to achieve that. If it's working, then you can leave it alone. And you can focus your efforts and time on the right hand, the ones that are bubbling out, the outliers. The reason that's effective is because the access to these systems, as you can imagine, when they're in a ceiling in an big open plan office with a prestige client, getting access to them is usually in the middle of the night. It's usually having to put ladders and spans over desks. Very tricky indeed. This is just another example of what you can do with that data. This is a approach we've been using called virtual metering. So adding metering to any building is always a great idea because it's going to give you insight about where you're using energy. Our thoughts on this are that depending on the accuracy levels you need, and in this case, we're providing metering without any additional metering equipment. We're just looking at proxies, so looking at valves, how open a valve is, what the temperature of the water going into it is, what its rating should be. And so we're assessing the impact of changes made to the building by looking at that data. This is virtually a year. This is a real example. This is where you can see on the right-hand side here, this is where an energy conservation measure was carried out, and the output of that unit dropped down dramatically, but then it experienced slipback, which is extremely common. Something happened in the building subsequently that was unexpected. So a lot of effort was put in to make that unit save energy, and suddenly it went haywire. What we're saying here is that you can use the same principles of metering just by using the raw data that you have. So where we want to go with this, I mean, we've talked earlier, Bill and Peter have talked about BIM. BIM obviously is really getting hold. The way we're looking at it is providing a fourth dimension to your 3D BIM model, the fourth dimension being time. So by assessing performance over time of all of these systems, we can add that real insight. Effectively, an augmented reality approach where you're wandering around a building looking at what's going wrong. And that's a little quote from one of our leading users. I think that this is the point about the volume of data. That's me. Thank you very much.
Hi, I'm Damon. I'm from OpenTRV, and we're almost a Trojan company. So you've heard a lot from startups in this session, and we are a startup, and we've been going a couple of years. Now, we came about because of this problem. That so the number you mentioned was 500 million being wasted from commercial heating controls. Well, something like 20% of the UK's entire carbon footprint is from home heating, from space heating. And we reckon about half of that is wasted. And that is £5 billion a year being wasted on domestic gas bills alone, which is quite a lot. We're actually interested, we are driven by carbon. We're here to try and cut carbon from a climate change point of view. And the ability, in principle, to knock 10% off the UK's entire carbon footprint while saving people money on their heating bills seems an attractive one, which is what we're doing. So we got into this because I was having lots of discussions with a chap called Professor Mackay, who became the chief scientist at DEC, and we were talking about all sorts of things which might make a difference to carbon at scale. And eventually I was asked to lead a smart heating workshop, and I did a little survey before the workshop, looking at what was out there already, and there were things like Lightwave and so on. There were some products out there, but they were all proprietary, so no interoperation, expensive. They're usually missing one of the critical features, which I'll come to in a minute. And because of the above, you wouldn't want necessarily to throw your money at them because you'll never get paid back. And secondly, you can't mix and match to get the behavior that you want. So it became obvious that there was an itch that needs scratching, and that's what OpenTRV is about, is to try and scratch that itch. And here is our solution to that particular problem. So I don't know how many of you have radiators at home for heating. Hands up, radiators. And who has those things on the top left? Yeah. And they're great, they're mandatory in all the building regs in the UK because they save a lot of energy and they keep a steady temperature. Human beings like steady temperatures. Turns out it's probably less important actually exactly what temperature it is than that it's steady. And they're very nice and simple, the mechanical ones. They're a little ball of wax pushing a pin up and down. They are a very good measure in their own right, but DEC, the Department of Energy's own surveys, show that most people do not turn down their heating when they're leaving a room or leaving a house even. So you've got this thing which is maintaining a lovely fixed temperature for you when there's nobody there. And that is one part of the waste. And the other part of the waste in a typical UK heating system is that the boiler is fired up by usually a single thermostat in the coldest part of your house that the boiler will be running in case you need heat anywhere. But the counterpoint of that is, of course, that it's running some of the time you don't need heat. So there's some more waste there. So what we were about is we thought, well, we can fix this. We can put a little bit of technology. You can replace that little ball of wax with something much more complicated and fragile. I mean, much more clever, with a little microcontroller in it. So something which looks like this. It thinks it's an Arduino, in fact. So it's got temperature sensor for the room, of course, and it's got some controls which you can interact with it. It's got a driver for the motor, and it's also got a light sensor, which I'll come back to in a moment. Anyway, the point is you put this into a unit like this, which is interchangeable with a new one. Note the only control, basically, is a twiddly knob like you have on a normal thermostatic radiator valve. So you don't need a complicated manual, you don't need an engineer to fix it or anything. The point is it can simply observe when you're typically in the room. It can observe room occupancy, and if it says, oh, there's no one in the room and there's no one likely to be at this time, then it can quite safely cut the heating without you ever noticing. And yet just doing that, you can get 10 to 30% savings. Now, we were doing this and we were thinking, this is handy because we might well have boutique hotels, say, who not only want just to regulate the temperature, but would like to know about volatile organics in the room or something like that. So we thought, oh, well, we'll put a connector on here to expand other sensors, and we'll make it so that we can monitor it remotely. So we have a little radio module on the back. And we suddenly thought, oh, this is what is called IoT these days. From an end user point of view, I'll tell you a bit, about the product. The idea is to get it to a tenner, by the way, per radiator, so anyone should be able to get their money back in a single heating season. Okay. Also, very nice if you're sneaking a box of tricks into a building that it costs a tenner, and not 150 quid, for example. No manual, simple to use. Okay, don't necessarily apply on the IoT side. Now, this is the user point of view. If it isn't a user buying the stuff for their own home, of course, the user is not the customer. This might be social housing. They would like to put this in so they can monitor things like humidity in every room, noticing when tenants are starting to dry their laundry inside with all the windows closed, which will then get condensation, which will then give respiratory problems and a big redecoration bill, or even activity. So his name has escaped my mind at the moment. The IoT guy at IBM, Andy Stanford Clark, says that in theory, I'm not sure whether he's actually done this or not, he can monitor when his dad goes into the kitchen. And if his dad hasn't gone into the kitchen by 10 in the morning to make his cup of tea, he knows something's up and he gives his dad a call. So, monitoring activity can be a very useful thing for vulnerable, so the elderly, for example. So we think, in fact, there's a whole strand of value to be had for example, utilities. You cannot any longer go on making more money by selling you more energy. We've got to use less energy, particularly less fossil fuels. I was pitching to Centrica this morning, by the way. And so we think they should be selling heating as a service where they keep you warm and they can reduce the energy that goes into that, and they can keep an eye on your health as well, for example. Anyway, the point about this is efficiency and monitoring, and this is absolutely IoT territory because we're talking about a cheap gadget which costs no more than the mechanical device it replaces, and yet has a radio, has this intelligence in it, monitors your usage patterns, can, at the moment, it's transmit only. We're working on the security element of being able to control it centrally. But it can be controlled remotely. So you put this in a university dorm, for example, and it's Friday evening and it's holidays and everyone's gone home and left their radiators on and their windows open. Then you, centrally, as head of estate management, press the magic button and everything shuts down. Or you're running an office block. And on Friday evening, there's one chap telling me he was managing a building with 400 radiators in it. On Friday afternoon at 5 o'clock, he had to send a security guard round to do nothing else other than turn down all the radiators. So you can do it centrally. This is IoT. It's just not very exciting like this. On the other hand, it can save you £300 a year as a typical homeowner. 5 billion a year to be saved across all houses. So here's another problem. So we realised we got IoT, and so we applied to these lovely Innovate UK people for their IoT launchpad. And we thought, well, we've got this nice box of tricks which does the radio and does the monitoring and has the microcontroller in it. And the issue we applied ourselves was to buses. So London, for example, the bus operator knows where every one of its buses is in real time, but it has no idea where most of its potential passengers are. And there are lots of opportunities to do things better if you do know where your passengers are. For example, Barcelona, I think, is trying to do a service where they basically don't send a bus out unless someone's waiting for it. Well, maybe we can't be that dramatic here, but if you ever look at a bus stop here, it says buses arrive every 6 to 12 minutes. So we are trying to measure footfall in bus shelters in a practical, good enough way that, in principle, the bus operator can say, oh, there's no one at these shelters, we'll send them out every 12 minutes. Or they're absolutely packed to the rafters, we'll send the buses out every 6 minutes. Maybe we'll even dispatch another one. Or we notice that a bunch of our buses are caught behind traffic, and we'll send another one out in front to pick up people who are otherwise being stranded. So we're trying to do this in a practical way at this kind of £10 per box price point. I mean, we're not going to be quite there. Now, an interesting point is how you get the data back. So it's been mentioned already, this idea of being secure from sensor to cloud, and that's very important, because if I take our engineering prototype of this, it talks to an existing commercial valve. That's not authenticated or encrypted at all, which means if I filled a nursing home with these, some bored teenager could sit outside and jam all their systems and shut the heating down in the middle of winter, which doesn't seem to me terribly acceptable. So you at least need authentication. We might not care that you're turning radiator valves on in particular rooms, but we do want to protect them against being tampered with. Equally, you might care about whether you're in or not, because if a burglar can sit outside, or a smart burglar, and observe, oh, there's no one in this house, and there hasn't been for 3 days because the heating hasn't been on, they could maybe go and take a jemmy to your back window on the assumption you're not around. So sometime you need encryption as well. Launchpad project, and here's where everyone has been promising I'm going to talk about open standards, and this is where I'm going to attempt to do so. I'd like to point out that each of these bricks was worth £50,000, all right, during the pitch. The pitch is to say, in fact, I should get them out of my bag and do them now. Imagine that the way we think they should be built is that you take a power unit which is appropriate to your... This has probably got a laser thing in it, hasn't it? Yeah, look at this. Get a power unit which is appropriate for your environment, so it could be mains, or it could be battery, or it could even be energy harvesting. Pick a microcontroller that's suitable for your application, so in this case, it thinks it's an Arduino Uno. In this case, pick a data backhaul that's suitable for your circumstance. So in the home, this is ISM band, which is the same as your baby monitor or what have you. For bus shelters, we'll probably be using something like LoRa, low power, long range radio. And then just snap on the couple of servers you want, the sensors you want. And as you put it together, that data starts turning up securely somewhere that's useful for you as a software developer, as 80% of people in IoT are. Most people in IoT, as practitioners, are in software, not in hardware, and they find the hardware aspect baffling and hard and expensive, and we're trying to fix that. But the radio is only one part of it. We've also got to agree what form the data should be when it leaves these things, hits the internet, and gets to you so that you can use it. Now, a point that was being brought up earlier was stuff's getting better and better. 30 years ago, my job before uni was working with a toy company on building a toy robot. And it had almost exactly the same computing power as this. Bizarrely, almost exactly the same, but used 1 million times the power. So I can now do things where I can have one of these running your radiator valve for 2 years off a pair of AA cells. Okay. You can't do that. You couldn't do that when the thing was drawing an amp. So what we're saying is, as the technology gets better, what do we do? Do we bring the internet to the devices, or do we make the devices smaller and cheaper and smarter and offload some of the security to a point between them and the internet? And so my view is very much that we should make the devices smaller and cheaper so you can deploy more of them and collect more data points, have a secure link, an appropriate link up to a concentrator, and then have that thing push the data out into the internet from everything like Twitter. So if you followed some of my stuff, you'd see I'm tweeting temperature from my front porch, as well as downloading into opensensors.io. But the important thing is that you do not bring the internet all the way to the things, because that means the things are too expensive and power hungry, in my opinion. Okay, and last point then. We are interested in gathering experiences from people who are actually practitioners in this or users of it. If you'd like to help us with our Launchpad project, which we're doing in public, and we're trying to resolve some of these security and interoperability issues, there are a couple of URLs. But if you search for IoT Launchpad OpenTRV, you would find us as well. So there we go.
Question for Damon.
Yeah.
As someone who's struggled for years with TRVs that do nothing until they get to about 3.5 when they come on, and go off at about 4 and seem a remarkably imprecise instrument, how long do you think it'll be before your smart TRVs at 10 quid a throw will be at my local B&Q?
This year we won't hit that price point. I was pitching to Ignite to help us with this morning to help us with funding for the first version. Our target is next winter. Now I can't promise we'll be exactly on a tenner, but we're going to be as close as I can make it. And that really is the entry point. You ought to be able to go and buy one of those and just fit it to your radiator, and it ought to start to save you energy. And that ought to be the end of it. Now, you can put more on, you can put the boiler thing, but yes, next winter.
Having worked with a number of BMS systems, so Trend and Preva and all those sort of things in commercial buildings, and also played with things like Z-Wave on a domestic scale, clearly, the issue is going to be how these things all work together, if indeed they do. With the TRV one, we're talking about a TRV, but you were talking about a hub, which would be the term everybody else would use. You didn't use that term, but you were talking about a box that connects to the internet, and then all the devices report to that. So essentially, it's a hub. All these different systems with different. We're getting back to VHS, Betamax, and all the sort of things that went before that. Where do you see this going in terms of all the systems coming together, having separate systems for commercial and domestic? I'd be interested to know where you see that going.
I think a lot of it's going to come down to open standards. And if you look at some of the plays that have happened in the UK or indeed globally around the Internet of Things, particularly for the connected home environment, you're looking at Google acquiring Nest, $3.2 billion. They've got a sort of open standard, but we're very much around HyperCat, which is the UK government, Innovate UK's funded open standards. So there's about 40 different companies in that consortium. But then, you've got big companies, Intel, Cisco, others that won't use HyperCat because indeed they're supporting their own open standards. So we're working towards those as well. I think it is all about interoperability. And in fact, we're creating a new terminology for this where you're talking about an interlayer. Where you actually have a layer of interconnected systems. That's really what asset mapping is all about. Bill can talk to that. But that's the way we see the market going, both in industrial and residential and indeed the commercial space.
So I would say that the concentrator, I'm calling it a concentrator because it might not be in every house, for example, and it might be one in London, for example, for all the buses. That is a place where you can put enough smarts these days because they're off-the-shelf things as cheap and ubiquitous as a Raspberry Pi to do a lot of translation for you. Now, it's best to minimize that, but that's the kind of place where you can, finely engineer transfer of data from one system into another.
Yeah, I think I'd echo what the others have said, but also that, from the commercial building point of view, it does seem that the industry is pushing them to an open standard. I mean, BACnet is becoming the industry standard language for a commercial building to talk, and we're seeing, I think pretty much the manufacturers don't really get away with having proprietary systems going forward, so that it seems to be going in the right direction, certainly.
Commercial buildings, believe it or not, are easier to integrate with because there are only a few, I think there's 36 different flavors of BMS, or the languages. Compare that to what's happening with Samsung, as Peter talked about, with Google Nest. There's 7 or 8 different open standards at the moment for IoT. And then you have all these additional companies creating their own standards, their own languages. So the domestic market is going to be a lot more complicated for the next 5 or 6 years than what's happening with the existing commercial market. But you're right, it is just a gateway, a collection point. However, the security has always been the big issue around those types of devices. And that's where, because you have the large organizations like Intel understanding the importance of security around IoT, there are starting to be a lot of minds trying to solve that issue. Because hacking a bank, although it's a problem, it's nowhere near that of hacking into a building and switching the entire power systems down. And that starts affecting companies' values. So with Canary Wharf, for example, that security piece for those gateways is incredibly important.
There's also one last issue I'd mention there. Yeah, these sort of devices are actually powerful computers in their own right. If you start embedding them into light fittings or different standalone devices, you've got a huge array of actually computing in the environment, and this really leads to this whole point about edge computing, fog-based computing, where you've got computing. It's all about change control. You don't want to know that something's and have petabytes of data saying everything's fine. What you really want to know is when you have an anomaly or a change, something goes off or it goes up to 28 degrees. And that's where you will see a lot more push, and indeed all the big people we're working with and Intel, Cisco, SAP, HANA are all about computing on the edge or before the data is actually sent up to the cloud.
And indeed you can do much smarter things with sensors if you can do some computation up front. So for example, in our handheld controller or the one on the radiator, I'm not using motion sensing. It wouldn't work very well at ankle height behind the furniture anyway, but doing some slightly clever stuff with input from a 12-pence light sensor. And because I can do some slightly clever stuff, I can get a lot more out of it than the raw sensor would be.
The building you mentioned, Mike, 1 Canada Square, I mean, that's going to be producing something like 7 or 8 petabytes per year. So looking at the security and then the open standards around that type of data, how that's shared, I would love to hear the panel's thoughts on how that data is going to be stored, how it's going to be used.
In terms of security, obviously we've talked about it a lot before, but it's paramount, just making sure that it's not easily accessible. And more importantly, that sort of the point about it being accessible is that we are only talking about building data at the moment, like how a building is performing. Much more important is not being able to write back into the building, so you affect how that building performs. In terms of the security, I think it's the same as any other challenge of security on the internet, is just keeping on top of the standards, making sure that your methods of storage are as impregnable as possible. But keeping importantly, keeping that stream from writing back into the buildings as well. I mean, that's our pitch on sort of cloud storage of information. The sharing of it, if you start to share it from that position, in the cloud, and as Peter mentioned, we're also adopting the Hypercat standard. It seems to be a way forward that's being widely picked up for all sorts of approaches as well. So from that point of view, if that information is transferred at that level, it means there's less. You've taken one link out, really, so you're less likely to be affecting a building directly, rather than if you were taking information directly from a building that's operational.
I'd jump in there as well. As I say, I've got a security background. I think the security, very simply, has to actually be fit for purpose. So you need to be able to work out what you need to protect and how to protect it, but also, of course, how to give people access to that. I think one of the big things here is actually looking at fine-grained control, admin rights around who needs what data at what time. And this is where we really see the control element of the Internet of Things in the built environment working. So when an engineer does respond to a job, they're going to be an accredited individual. They're going to know Bill can talk to this as well, the location of the asset, what the fault of the asset is, the history of that asset. They're going to be not only have the right equipment and skills to repair that, they'll also have the right accreditation when they walk into the building to gain access to the location of that asset, as Mike said, at the appropriate time to effect that repair. So all of this is about fine-grained control. There's a number of systems out there that do that, and we're examining and working with a number of vendors who have that type of technology.
And just adding something, security, of course, applies at several places. So a lot of this stuff is now delivered wirelessly over RF. So you've got RF components that you have to protect, and I was suggesting that the components should be getting smaller, thus it's quite tough for small devices with small power and small CPU power to actually do the appropriate level. You've got the transfer across the wired networks and the internet. You've got security once it's in a database, for example. All those have to be right in the sort of way you're talking about.
and appropriate. So sometimes it doesn't matter. Sometimes you don't care about some data at all. It can just be there in public. Sometimes you want to authenticate so people can't spoof. And sometimes you actually want to protect that data. There may be privacy or security implications if you don't. So it's a very multifaceted thing. There isn't a single, I used to have people rush up to me and say, oh, I've got a security system, a bloke with a sort of tatty woolly sweater, who clearly thinks that putting it in that safe and burying it at the bottom of the sea is the answer. It isn't. If you want a usable system that is secure in the right way, it's quite a nuanced problem over quite a number of attack surfaces that you need to think about. Of course, getting one of them wrong can undermine the whole thing. And the big lesson, of course, is don't roll your own, if you can avoid it.
Yeah. Mike, you touched upon the challenges around commercializing this type of innovation, new technologies. I know, Peter, you're a startup, and Damon, obviously, with what you're doing. Can you just talk a little bit about the challenges around, we talk about smart cities with this great buzzword, but really how do you take a new innovation and commercialize it?
No, that's a good question. For us, the biggest challenge was, I guess, persuading people that they were likely to have the problems that we believed they did. And that's really because of exactly the problem that we're trying to raise, which is there's a huge volume of data. There's a big assumption with a lot of people sort of running commercial buildings that if they've already invested in a system that's running their building, that means that investment, that's all done. The building is now working properly, and the assumptions are that, it's all swinging along nicely. The thing that was difficult to get across, the message that was difficult to across was, I guess, the same message I've been trying to get across, is about the volume of data that's involved in making, or the volume, it's not just data, it's about the volume of components and the physical things that make a large building work. There are hundreds of thousands of little tiny pieces of electronics that should all be interacting properly. So getting that message across, and then also convincing them that there was a commercial story in that for them, in that there'd be an energy saving. There's also the less tangible things about maintenance savings, that there are maintenance savings by using your resources more effectively, and also maintenance savings in plant. So if you find a large chiller that the size of an articulated lorry that is going on and off every couple of minutes because it's being told to by some system, and that's going unnoticed, that the life expectancy of that machine will be reduced dramatically. So those less tangible savings for a company to make. So it's kind of a complicated story to get across. The other big challenge is also about your own integrity, and about, if you're a startup, typically for us it's pitching to big companies, so you're pitching to blue chips. Trying to get a blue chip to buy into the idea of a startup is pretty hard. They're much more likely to buy from a big known manufacturer. And we found typically something like a 1 year incubation period from the first dialogue with a major company to actually turning that into an order. But once you're up and running, and once you've got your first case study, things do change dramatically, and hopefully, you touch plywood. We're on that roll at the moment.
I've been doing startups for some time now. This is about the 14th or 15th startup I've been involved with. I'm also, do a lot of sort of consultancy around startups. So if you want to talk startups, I'm happy to go into a deeper dive after the session. But, generally speaking, I echo a lot of Mike's points. I think, having that idea, putting the company together, doing all the kind of logistics stuff, raising kind of first capital, getting out there, making the contacts. The thing that's really quite good in London at this point in time is the amount of interest that a lot of large companies are putting into innovation. A lot of them I don't think are doing it terribly well, but they're now starting to employ people who are looking at bridging the gap between what they can do in-house in their own R&D departments and what they can do with startups and small companies that are actually quite innovative. Innovate UK, of course, is sponsored today. It triggers a lot of that between getting both industry working with academia, but also with SMEs. And I think any smart SME company here in the UK would be party or at least bid in a collaborative joint bid process for some Innovate UK money, and I think most firms would go that route. There's also a big and increasing startup ecosystem here, including venture capital. The UK government, of course, through EIS and SEIS, Enterprise Investment Scheme, and Seed Enterprise Investment Scheme, sorry, I'm buzzing, offer tax incentives for basically high net worths to invest in startups. Those schemes are very popular, so it's reasonably easy to get angel capital in the UK right now. The problem really is this funding gap between, as Mike said, getting your first customer, getting reference customers, building your revenues, and actually then going out to raise a proper Series A round, which is, depending on the size of the company, £1 to £2 million. I think that's where a lot of British firms are still moving to America, or where the American VC market is a lot more risk preferring than what we see in the UK, which is more about development capital.
All that you say is true. It turns out that I'm not nearly as good at startups as you. I'm only on about 3 or 4. So I'm the young boy around here, but doing them for 30 years, and I'd say this is as much fun as I've ever had in 30 years in terms of the environment. It's no longer evil to be an innovator or an entrepreneur. I can say that word without being stoned. That's very good. We've got an interesting particular problem that OpenTRV, we are motivated by carbon cutting. We have a strong social goal. We're not interested in acquiring yachts or islands in the Bahamas or what have you. Although if anyone offers us one, we'll take it. And that makes an interesting extra problem that we have to find a protectable business revenue amongst the stuff that we're trying to do in public. So we want everything as much as possible to be open source and public, but we need to have a protectable source of revenue. And we find we have to pitch very differently. So this morning's one with a social impact one, and it was all about carbon and health and stuff. And I did a pitch a few weeks ago to Master Investor where the chap I was pitching to doesn't, I don't think, believe in global warming. So I had to do a completely different pitch, which is just about the energy savings. And that's an interesting dilemma, I think, which is going to affect us, which doesn't affect some other people in this sort of area, where we've got a social mission, but sometimes we have to pretend we're just red in tooth and claw.
You both reminded me of things. One is about Innovate UK, because we have landed a funding round from Innovate UK, and it's been really key for us, and we're working with London South Bank on that as well. Another point really was about open source, because a lot of our platform has been built on open source elements. And as a company, we have a commitment to going open source. The challenge really is how and where and what to do that still provides you with a revenue-generating business. But we do have like Damon, we do have a commitment to go open source with our software at some stage.
One last question, because I love this one. It's about smart cities.
Yeah, bye.
What is a smart city? Can you give me a sentence, a couple of sentences on what a smart city is for you?
What about measuring and managing? It's the old business adage that if you can't measure it, you can't manage it. And I think I think our interest in, if you get IoT right, it isn't about snake oil, it's about being able to measure more things at a reasonable price point, which means you can manage them more effectively, whether it's your bus fleet or your home heating.
I guess it's a city where you're using technology really for, rather than just technology for technology's sake, but for things that actually make the city work better. I mean, seeing things like integrated transport apps where you can actually find out the best way to get from one place to another. Things where the buses are telling you where they're coming. When the buildings, from a building's point of view, the interesting stuff for us is about, demand response in terms of helping the national grid to overcome peaks in supply. So where, if you're on a pinch point on the network, if you can get those buildings to interconnect with one another and to agree to not overpeak, then that's a kind of utopian way of looking at the grid. So when you're working at that level, you're looking at every single light, every single valve in a city all interacting together. It's quite an exciting idea. Yeah. I think there's a lot of spin about smart cities, but I think there are genuinely really exciting things to come.
Okay. Peter, a definition?
Yeah, I'd actually say right now there isn't such a thing as a smart city. But, to my fellow panelists' points, it's heading that way. Technology is becoming more available. Systems need to talk to each other better. I think a lot of larger vendors have come unstuck in the past when they've tried to sell a siloed one-system-fits-all solution to people. And I'm not going to name names, people are very aware of a number of instances where this has backfired quite spectacularly in some cases globally. And I think even these vendors now are again, trying to find innovative companies. They're talking to the likes of people here and looking at how they can use technologies like the ones that we're promoting to really begin to integrate disparate systems. I think it will be a bit of an 80-20 rule to start with. People will work with the larger vendors who adopt more open standards, and that will become the solution that goes to market first. But to Mike's point as well, we all use things like Citymapper, and we can all see how open data standards are really starting to change things. I'm also a big proponent of big data analytics, and I think the truly smart cities of the future are really going to come about when we start looking at the metadata aspects of what systems like asset mapping will start to collect, where you can have vast quantities of data from a number of different estates or buildings, and really anonymize that data, but you'll be able to see really by asset class or even part number or type of asset or manufacturer how those assets truly perform over time. And then you can use systems like Mike's System and Energy Deck and a number of other companies that we're working with. And don't underestimate how the SMEs are working together. We've got projects with these guys. No doubt we'll talk to Damien as well.
And we're working with Energy Deck. There you see.
There you go. So it's a small world, but very active and fertile world in the SME space. And we'd like to really try and make cities smarter. But also, I don't buy the hype. I think there's been way too much of it.
Yeah.
Okay, I think we'll... one more? Okay, no, that's it. No. Unless anybody's got a question, we'll close the session. Okay, thank you very much. Thanks for your time.